Sequences in series, non-linear sequences. So in this section, we're going to be looking at quadratic sequences, and the first type we're going to look at today is the method of differences. So if, for instance, we look at this sequence here, 8, 14, 24, and 38, when we were doing our arithmetic sequences, what we were able to see was that if this was term 1, term 2, term 3, and term 4, then if it was an arithmetic sequence, term 2 minus term 1 was known as the common difference. Common difference meaning that every term was separated by the same number. Now, if I subtract 14 and 8, I end up with 6. In other words, 8 plus 6 gives me 14. Now, if I do that with the next set of terms, the next two consecutive terms, what we notice is we don't have a constant. In other words, to get from 14 to 24, I'm adding on 10. And if I was to go from term 3 to term 4, I'm adding on 14. And we could continue this infinitely and see that there is no constant between each of these consecutive terms. In other words, what we say is the first difference is not constant. Now, if it was constant, that would mean it was a linear sequence or an arithmetic sequence. So because it is not constant, we say, therefore, it is not arithmetic. And when we drew our graphs of our arithmetic sequence, we saw that it was linear. So therefore, it's not linear. However, if we look at the differences between the first differences, what we can see is that if I look at 6 and 10, well, the difference between those is 4. And the difference between 10 and 14 is also 4. So now what we actually see is that the second difference is constant. And because the second difference is constant, we say that this is a quadratic sequence. So it's going to be of the form an squared plus bn plus c. So we know that from algebra. We normally would say 2x squared minus 5x plus 3, and that's a quadratic equation. So in this, our sequence is a quadratic sequence, which will take on the same form. Now, if I also wanted to find the next term, what's interesting to note, if I use a different colour here, is that if I get 6 plus 4, I end up with 10. And if I add 10 to 14, I end up with 24. If I go 10 plus 4, I end up with 14. And if I add 14 to 24, I end up with 38. So if I wanted to know the next term, well, I know my second difference is going to be 4. So we would say 4 plus 14 gives me 18. And then if we add 18 to 38, well, we would get 56. So we could fill in our next term there would be 56. And we could continue that process on where you keep adding the first difference and the second difference to get to the next term. So adding the first and second difference will give you your next term. So 14 is term 2 plus the first difference and the second difference will give me the third term. And 24 plus 10 plus 4 is going to go me from the third term to the fourth term, and so on. So let's take one more example there. So if we have 1, 3, 6, and 10. So we have a sequence 1, 3, 6, and 10. So term 1, term 2, term 3, and term 4. And it says, show the sequence is quadratic and write down the next 2 terms. So to show it's quadratic, we must now know that our second difference has to be constant in order for it to be a quadratic. So we start and we look at the first difference between each of these terms. So term 2 minus term 1 is 2. Term 3 minus term 2 is 3. Term 4 minus term 3 is 4. So we can see that the first difference is not constant, so it is definitely not linear. So that's our first difference. So difference between each term is what that means. And then the difference between the differences is called the second difference. So therefore, 3 take away 2 is 1, 4 take away 3 is 1. So we can clearly see then that the second difference is constant. Hence, it's quadratic. Okay, so now we need to write down the next 2 terms. So in other words, we have to write down term 5 and term 6. So our term 5 is going to be 10 plus the first difference, which is 4, plus the second difference, which gives me 15. And then term 6 is going to be 15, so the fifth term, plus the next difference. So let's work out what that difference is. So our difference between our fifth term, if we put in, is 15. All right, just do it like this. So our next term was 15. So the difference between 10 and 15 is 5. Difference between 5 and 4 is 1. So therefore our next term would be 5 plus the second difference, which gives us 21. Okay. So if you go to page 213 and just do question 4, where you're writing down the first term, the first and second differences, and then the next 3 terms. Okay, so type 2 then is going to be our general term. Which is going to be given by an squared plus bn plus c. So we have to look at how can we actually come up with a general term for these quadratic sequences. And again, this is not going to be in your tables. So before we look at how to do these questions, we need to figure out what is the relationship about this second difference. So in order to do that, we're going to look at the terms either side of the general term for a quadratic equation. So we know for a quadratic equation that the second difference is constant. And we need to know, well, what is that constant? So let's look at 3 consecutive terms. So we're going to say t of n is equal to an squared plus bn plus c. So if I get the term to the left and to the right of that, that would be 1 less and 1 greater. So we'd say t of n minus 1, t of n, and t of n plus 1 would be the 3 consecutive terms. So t of n minus 1 means wherever there's an n, we're going to put n minus 1. And if I simplify that, well, I have n minus 1 squared, so that's n minus 1 times itself. So that's n squared, multiply them and double it, and square the second term. bn minus b plus c. So that's an squared minus 2an plus a plus bn minus b plus c. And then if I write down t of n plus 1, so again, wherever there's an n, we'll put n plus 1 this time. And that gives us a times n squared plus 2n plus 1, bn plus b plus c. So that's an squared 2an plus a plus bn plus b plus c. Okay, so let's look at the first and second differences between each of these terms, okay? So in other words, I'm going to set up t of n minus 1 followed by tn followed by tn plus 1. So we have t of n minus 1 is an squared minus 2an plus a plus bn minus b plus c. And then t of n is an squared plus bn plus c and an squared plus 2an plus a plus bn plus b plus c. So if we were to get the first difference between each of those, so in other words, if I was to subtract and subtract, well, what do I end up with? So I have an squared minus an squared would be 0. I have bn minus bn would be 0. And I have c minus c, which would be 0. And then I have minus 2an would become plus 2an, minus a, and minus b would be plus b. So that would be my first difference there. And then if I get the difference between the next two, let me just expand that bit there, so that's plus c. So an squared minus an squared is 0, 2an, and then I have a, and then I have bn minus bn is 0. I have b, and then I have c minus c, which is 0. So that's my other difference. And then if I get the difference between these two terms, we have 2an minus 2an. A minus a is 2a, and b minus b is 0. So what we have is our second difference is always going to be 2a. So we need to know this off by heart. Okay, so that's always going to be the case. So there's two approaches you can take to this question. And in my revision sheet, you'll see the two different approaches. But the easiest one is always to just go with the simultaneous equation approach. So that's the way I'm going to do it for this section. So if we have, for example, our quadratic sequence here, we're told it's quadratic, then we know that our equation is going to take the form an squared plus bn plus c. Therefore, we need to find a, b, and c. So to find a, well, what we have to do is get our second difference, and we know that our second difference will always be equal to 2a. So let's look at our second difference. Well, we have 6, 12, 20, 30, and 42. So that means if I get the first difference between each of these numbers, 12 minus 6 is 6, 20 minus 12 is 8. 30 minus 20 is 10. And 42 take away 30 is 12. So again, as we see, the first difference is not constant. And therefore not linear. So not arithmetic. And therefore, if we look at the second difference, I can see clearly it's going up in twos. So 8 minus 6 is 2, 10 minus 8 is 2, 12 minus 10 is 2. So our second difference is constant, therefore it is definitely a quadratic. So once we know what the second difference is, so because the second difference is constant, we know it's definitely quadratic, and therefore we say our second difference is 2a. So we say 2a is equal to 2, which means that a must equal 1. So now we know what a is. So step 2 is to find b and c. So to do this, we're going to look at our sequence, which is 6, 12, 20, 30, and 42. We have term 1, term 2, term 3, term 4, term 5. So we know that term 1 is equal to 6. So if that's term 1, that implies that n is equal to 1. We know that a is equal to 1. And therefore, if our equation is of the form an squared plus bn plus c, then when we have, when we have n is equal to 1 and a is 1, and we sub into our general equation, that will give us 6, because that is our first term. And therefore we end up with 1 times 1 squared, which is 1, plus b plus c is equal to 6. And therefore we end up with b plus c is equal to 5. So that's our first equation. So therefore, if I look at the second term, it's equal to 12. And therefore that implies that n is equal to 2. A is constant, it's 1. And therefore, if I sub into, again, my general term, an squared plus bn plus c, well, a is 1, n is 2 this time. B we're trying to find, n is 2, plus c, and that term is 12. So we have 1 times 2 squared, which is 4, plus b times 2 plus c is equal to 12. So we have 2b plus c is equal to 8. So now we have two equations in terms of b and c. And I'm going to multiply the first one there by minus 1. So that gives me minus b minus c is equal to minus 5. And then we have 2b plus c is equal to 8. So therefore my c's will add to give 0. We have minus b plus 2b is b. And minus 5 plus 8 is 3. So now we know what b is. We can sub b into equation 1 to find c. So that gives us 3 plus c is equal to 5, and therefore 5 minus 3 is 2. So now we have a, we have b, and we have c. So all we have to do now is sub into our general term. So t of n is equal to an squared, so that's just going to be n squared, plus bn, so that's going to be 3n, plus c, which is 2. So in other words, if I was to sub in, for any value of n there, I would find every single term in this sequence. So let's have a look. If n is equal to 1, that means that the first term would be 1 squared plus 3 times 1 plus 2, which is 1 plus 3 plus 2, which is 6. If n was 2, that would mean my second term is 2 squared plus 3 times 2 plus 2, which is 4 plus 6, which is 10, which is 12. And of course, if you look, they are our first two terms in this sequence. And you could go on. So in other words, we could be asked to find the 50th term, and all you would do is sub in for n is 50. Okay, so let's do one more example. Okay, so here we have 68, 44, 28, and 20. So again, we're going to start with step 1, which is finding a. So to find a, we need our second difference. So we have 68, 44, 28, and 20. So we have term 1, term 2, term 3, term 4. So if I get the difference between each of those consecutive terms, well, we have 44 minus 68 is minus 24, because clearly this is a decreasing sequence. 28 minus 44 is minus 16. 20 minus 28 is minus 8. So that's our first difference. And again, not linear. And we're told it's quadratic anyway, so we would expect that to be the case. And again, if I get my difference, so I have minus 16, and be careful here, minus 24, which is plus 8, minus 8 minus minus 16 is 8. So just be careful of your signs when you have a decreasing sequence. So here we have a second difference, which is constant. And that means it's definitely quadratic. And therefore we can say that the second difference is equal to 2a, which is 8. Hence a is equal to 4 this time. So as I said, we always say our second difference is constant, which is equal to 2a. So we need to know that off by heart. So step 2, then we're going to find b and c, and then the general equation. So therefore we're going to start by saying, well, my first term is 68. So what that means then is when n is 1 and a is 4, well, what will the general equation look like? Well, it's t of n is equal to an squared plus bn plus c. So therefore a is going to be 4 times n, which is 1, plus b times n, which is 1, plus c. And that first term is equal to 68. So we're going to have 4 plus b plus c equals 68. And therefore b plus c is equal to 64 will be our first equation. The second term in the equation, there was 44. So then that is telling me that when n is 2 and a is 4, what will the general term look like? Well, it's going to be a times n squared, b times n plus c is equal to 44. So we've 2 squared is 4 times 4 is 16, plus 2b plus c equals 44. Therefore 2b plus c is equal to 44 minus 16, 28. So that's going to be equation 2. So I'm going to multiply the first one by minus 1. So we have minus b minus c is equal to minus 64. And then we have 2b plus c is equal to 28. So c and minus c is 0. 2b minus b is b. And minus 64 plus 28 is equal to minus 36. So now we have b. So I'm going to sub b into 1, which is minus 36 plus c is equal to 64. And therefore C is equal to 64 plus 36, which is 100. So therefore we say our general equation an squared plus bn plus c is going to take the form of 4n squared minus 36n plus 100. Okay, so let's go to our books then on page 213. And you're going to do question 5, part 2, 3 and 4. And question 6, we do part 4.